Hello, welcome back to our channel. It is our lecture number 4. We are continuing with our math series questions. So here is our next question. In this question, we need to find the trailing zeros in a factorial. Okay, so all you have already seen how to calculate the factorial of a given number. If you haven't know, just check out my video. The link is in the description. Okay. So let's continue with this question. What you have to do in this question, as you can see, if we give the input 5, we will get the output 1 because first first we will take the out the factorial of a number. The factorial of 5 is 120, and then we're gonna see how many zeros are present from last. Okay, not in between, just from last. Okay, so here you can see total one zeros is present, so the output is 1. Then again we can see when we input 10, then the factorial of 10 is 3628800. In this, last two zeros are present, and then again for 124 zeros or 24 zeros are present. So in this way you gonna do this question. Okay, so let's just pause the video and try to write the function which takes the number as an argument and just return the uh, count of zeros it has. So let's just move on to the solution. Okay, so let's just think the solution that is in our top of the head, that first we came across this solution. That is the first step is to get the factorial of a number, which we have already seen in our previous videos. Okay, either way we can do iteratively or recursively. Okay, then what we gonna do in second step, what we gonna check the number of zeros it has. So in second step, what we gonna do, we just gonna run the while loop or a for loop over a number and just use the modulo operator and take out the remainder. If the remainder is equals to 0, then we gonna increment the counter by 1. If it is not equals to 0, then we will do nothing. Okay, so we can do in this way. Let's just code it up and see how we can do this. Okay, so let's just make an function. Let's just make an function fact, and let's just fact. And so in this function we gonna return. So instead of void, we gonna use an integer. So in this, what we gonna do, first we gonna first steps to get the factorial of a number. So how we can get the factorial of a number? So to get the factorial of a number, we can do it both the ways. Just do it. So okay, so return 1. That's what we're gonna do. Return. Okay, so from this function we will get the factorial of a number. Then let's just see, let's just write the function for trailing zeros. Okay, trailing zeros. Let's just, so here, so when we return the factorial from this, we just need to input it over here. Let's just see factor. Then what we gonna do is we gonna run while loop, or we can also use the for loop. Let's just run while loop. Okay, while loop, what condition we will put, that if factor percentage 10 equals to 0. If it is not, we not gonna increment the count. Let's just increment the count. See over here, and let's just make the count equals to 0. Okay, and now let's just return our what we want to factor equals to factor divided by 10 and just return the count. Okay, so now from here we will get our factor. Okay, so here we will get our factor. Now let's just call the function which is trailing zeros. Let's just enter the factorial value that we have got, which is stored in the factor variable. Now int num equals to, let's just print the count of cout the zeros in given number is. Let's just run our code and see is it working fine. So let's just enter the number. So our number, let's just enter 5. So yeah, it is working fine. As we can see here, the output is 1. Okay, let's just again run it. Now let's just run it for 10. Let's see it is working fine or not. Okay, it is also working fine of 10. Now just run it for 100. Okay, so here as you can see there is no output. So this is because the integer can only store the int value can only store up to the 19 values. So which is more when we do the factorial of 100. So in efficient solution what we can do, number, like for example if a number is 10, okay, so see how many 2 and 5 pairs are there, because 2 into 5 is 10. So the number of 2 or 5 pairs are there, the number of zeros will be there. Okay, if in a given number till n, like here you can say is a 1 pair. Okay, then other is this 2 into 5 which is 10. So there are total 2 pairs of 2 into 5. So here we get our answer as 2. Okay, same way we can do for 5. Till 5 we have only 2 into 5 which is 1 pair, so we will get the answer 1. Okay, so in this we are not storing the factorial numbers, so it will not exceed our limit. Okay, so here as we can see till 10. So instead of calculating 2 and 5, 2 and 5 pair, what we can do, we can just see the number of 5, because there will be no existence of 2 if 5 is not there, because 2 into 5 is 10. So at least the 5 has to be there to make a number 10. Okay, so till 10, here are till 10, and here we can see there are two fives and 25s, and till 125 there are two fives, and from 125 there will be three fives. Okay, so here just what we need to do. Okay, let's just run our loop from int I equals to 5. Okay, till I is less than equals to n, and each time we are looking for number of 5, so just we need to increment by multiple of 5. Okay, so what we're gonna do is just make a resultant and just add the resultant each time we divide a number by 5. Okay, so when we divide it, okay, for example our number is 10. Okay, so 10 divided by 5 is 2. Let's just put our resultant rest equals to 0. Okay, so whenever, for example, our number is 10, so when we divide our number by 5, 10 divided by 5 it is 2, so we will get the answer 2. After that, when we will multiply it, it becomes 25. So 25 is greater than 10. So we will come out of the loop and just return our answer, which is yes. Okay. So, so let's just run our code. Let's just enter the value. Let's just enter the value for 100. So here we will got 24. Before we are not getting because the number of the numbers that can hold by an integer is only up to 19, and the factorial of 100, it contains more number than 19. So let's just meet in our next video lecture. Till then, bye bye.